So by default the value is 600. As you can see, I place the finger on the LDR. So value goes below 300. It means the LED turns on. I remove the finger, LED turns off. See, I place the finger again, LED turns on. So by default the value is 600. It means the light at this point in the room is the 600 value. So I had set the threshold to 300. That whenever it goes darker than 300, the LED turns on. See, LED turns on whenever the value falls below 300, and when it goes above 300, it turns on. See, at this it's conflicting, above or below 300. So whenever value goes below 300, LED turns on, else it's off. See. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a PIC16F877A microcontroller with an LDR sensor and display the output on 4-digit 7-segment cathode type display. Then we are also going to use an LED. We will set a value manually. Whichever desired value we select, whenever the value will go above that desired value, then the LED will turn on, representing that there is light in the room. And when it will go down, it will be the opposite, that it will turn off. So we can take it as an indicator that there is light in the room, like light or dark. That's all. So let's get started. So guys, this is the 7-segment 4-digit cathode type display I'm talking about. It has 6 pins at this side and 6 pins at the other side. From the top it looks like this. And then guys, at the top side, at the back, we have 6 pins. At the bottom we have 6 pins. Let me label them for you. At the top left, at the back, you have digit 1 pin to the left, then A segment, F segment, digit 3, digit 2 and B pin. Then at the bottom left you have E pin, segment D pin, segment dot pin, then C pin, then G pin and then the digit 4. Now guys, here digit 1 pin, this pin, whenever you will connect it to the common ground, in case of a cathode, you will connect it to the ground, this digit, that is a digit 1, will get enabled. Or in case if you connect it to a microcontroller, then you have to send a 0. Then this will get enabled. In case of a anode type, it's opposite. You connect it to the power pin, that is the 5 volt, then this digit gets enabled. Or in case of a microcontroller, you have to send a 1. Then digits get enabled. But we have a cathode, so we have to send either a 0 or connect it to the ground manually. Now this pin digit 2 correspond to this 7 segment. Digit 3 pin is for this, and this digit is a digit 4 represented by this pin. So guys, now this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is our 7-segment cathode type display. It's the top view. Now let me label it again for you. At the back, top left, you have digit 1, then A, then F, then digit 2, digit 3 and then B pin. Then at the bottom left, you have E, D, dot, C, G and D4 pin. Now guys, let's connect it with the PIC. You will need now this digit at the left is the digit 1, digit 2, digit 3, digit 4. Now to connect it with the PIC, you are going to need 8 220 ohm resistors. These resistors are basically safety resistors. Like for a normal LED, you use a resistor for safety purpose. That's why they are here. Now first of all, for the A pin of the 7th segment, connected to the one end of the 220 ohm resistor, then from the other end of the 220 ohm resistor, you can send it to any available digital input output pin. I'm going to use the port B for this. So I'm going to use the pin number B0, that is pin number 33 of the PIC. Now for the B pin, connected to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, send it to the pin number B1. Then for the C pin, connected to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to the pin number B2. Then guys, for the D pin, connected to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to the pin number B3. Then for the E pin, connected to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to the pin number B4. Now for the F pin, connected to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to the pin number B5. Then for the G pin, connected to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, send it to the pin number B6. Then for the dot pin, connected to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, send it to the pin number B7 like this. In this way, our 7 segments are connected. Now guys, remember that I use the port B. Here 0 correspond to A, 1 correspond to B, 2 correspond to C. If you want to use any other port like port D, C, or you are using other microcontroller of the PIC series, then you might have other port which have 8 pins. Then remember that 0 will always correspond to A, 1 to B, 2 to C, because we are going to use a MikroC 7 segment tool. That only works if you follow this sequence. If you make a manual sequence, then you have to write a manual library. You cannot use the MikroC tool. So I suggest you follow this sequence. You can use other port like B, C, D, but this must be same. 0 for A, 1 for B, 2 for C, 3 for D, etc. Now guys, for the digit pins, you do not need a resistor for the digit pin. You only needed 8 resistor while we have 12 pins. Now the rest of the 4 pins are for the digit enable. Now guys, I will connect the digit 1 pin. You can use any available digital input output pin for this. I'm going to use the pin number D0 of the PIC for digit 1. For digit 2, I'm going to use the D1. For digit 3, I'm going to use the D2. And for digit 4, I'm going to use the pin number D3 of the PIC like this. Now guys, we have our LDR. Now we have our LED. Now let's connect these two as well. For the LDR, you know that one pin is the value, other pin is the 5 volt. You can shuffle these two pins, doesn't matter. For the LED, shorter pin is always the ground and longer pin is the 5 volt pin. Remember that you can never shuffle these two pins in an LED. You cannot. If you shuffle them, then this LED will be burned. So 5 volt is or the power pin is always the longer pin, ground pin is the shorter pin. Now guys, let's do the wiring for the LDR first. First of all, connect the 5 volt pin of the LDR directly with the VCC. If your V reference is different, then that doesn't matter. In the formula, you only change the values. Now the value pin, that is the other pin of the LDR, you will need a 10 kilo ohm resistor for this. You will connect it to the one end of the 10 kilo ohm resistor. Then from the same value pin, you will take your output out. You can use any available ADC pin for this. I am going to use a pin number A0 because it's available in my project. You can use any other ADC pin as well. Now from the other end of the 10 kilo ohm resistor, you will send it to the common ground like this. Now for the LED, connect ground pin to the ground like this. Now for the 5 volt pin, you are going to need a safety resistor. 220 ohm is good enough. You will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can use any available digital input output pin of your PIC. I am going to use pin number C0, that is pin number 15 like this. In this way guys, our connections are completed. Now we can move forward towards the programming. So let's get to the MikroC. Let me first introduce you to the hardware before we get to the MikroC for PIC programming. So guys, this is the hardware here. You can see that. Let me move these bars. So this here is the LED. This is the LDR. And this is the 4-digit 7-segment display I'm going to use. This at the back is the PIC16F877A. There is the PIC at 3.5. So guys, let's get to the MikroC for PIC. So let me zoom in. This is the MikroC for PIC version 7.2.0. You can use the higher versions as well. I click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. LDR 7-segment LED tutorial learning microcontrollers. This is the name I wrote. PIC16F877A is the one I am using, and 20 MHz is the crystal I am using. Click on Next and click on Finish. Now guys, before doing anything else, you will get to this window. You have to first save your file. Click on the screen and press Ctrl S and save wherever you prefer like this. Now guys, first of all, we initialize our LED pin, that is at tris C.F0 at C0 pin. F0 equals to 0. 0 means it's an output. In case of an Arduino, you will write like pin mode output. And initially the LED must be off. So initial state is off like this. Now give some initialization delay. 20 will do fine. They are not, this initialization delay is not important, but I give it because I use old PIC microcontrollers as well. So now we have LED initialized. Now we initialize our 7-segment display. So it's at port B equals to 0x00. Complete port B is declared as output. Oh sorry, port B initial state. It must be tris B. Tris B equals to 0x00. It's now initialized as output. Like in case of Arduino, it's like pin mode. Now the initial state, write down port B equals to 0x00. All the LED by default must be off. So give some initialization delay. Here our 7-segment is initialized. Now guys, the next thing is our LDR. For that we will need the ADC library. Go to right, expand this. and here you have ADC. Just check mark this, so this library is checked. Now use the command ADC underscore init double bracket. Now give some initialization delay as well here. Now this command initialize all the ADC pins of the PIC microcontroller. Now for the 7th segment, we need to declare the characters. For that, we will need an array of char. So we use integer int display maximum 10 digits, like it will be 0 to 9. For that equals to, now go to the tools. There is a tool called 7 segment editor. You open it up, this pops up. Now on this screen, make a 1. Click the segments. This is the 1. Now when you zoom in, you will see that this is the common cathode decimal value. For the common cathode, it's 6. So just copy it and place it in the array 6. Now we also need a 0. It's 1. So make a 0. Now to make a 0, just connect this and this. Now it's a 0. It's 63. Now place it here. So remember that sequence must be maintained. For display 10, so the first, that is the 0 digit, it's 0 to 10 means 0 to 9. So 0 digit is 63, it means display 0 means it's a 0 on the 7th segment. Now it's 1, display 1 means it's a 1 on the 7th segment. Now make a 2 to get the display 2. To make a 2, just do this. Okay, it's a 2 now. Look for the common cathode value like this. Now make a 3. This is our 3, 79. Now make a 4. Now this is why I was telling you, you have to maintain 0 for A, 1 for B. If you don't maintain that, you will not be able to use this tool. Okay, this is 4, 102. Now make a 5. So this is the 5 and 5 is 109. Now make a 6. Just connect this. So 6 is 125. Now make a 7. Now make a 8. All the LEDs will be on for the 8 like this, and 8 is 127. Copy it. Now the final digit is the 9. Let's make a 9 and see what digit we get for 9. Now this is the 9. So it's 111 for the 9 for the common cathode. So place it here. So now close the array and add the semicolons. Now this is an array which will be making digits for the port B. Now we can go to the forever loop, write down while 1. Forever loop starts here and ends here. Now first of all, we will need to read the value from the sensor. For that we will need an integer which will store the value, and a variable we write value, val. That's all. Now val is equals to ADC underscore capital R EAD read 0. Now this is the command and its syntax. This is the integer variable which will store the value coming from the sensor, and this is the channel. I am using pin AN0, so I wrote 0. If you are using 1, just make it 1. That's all. Now give some initialization delay. This is fine. If you don't give delay, doesn't matter, but it's a good practice to give some delays. Okay. Now we have our LDR value. Now next thing is to display this value on the 7th segment. For that, we will need the digits. Now we declare the digits. This is the 7th segment. Now on the port D, let me show you. On the port D, you see that we have 4 digits pin, D1, D2, D3 and D4. Now we declare these pins. So write down tris D equals to 0 cross 0 0. The whole port I declare the output, while we are using only 4 pins, but I have nothing on the port D, so it's fine. If you have something, then you declare them one by one. So port D is now output. Now the initial state, port D equals to, now the initial state is somewhat tricky for the cathode. I use this technique 0B 1 2 3 4 5 6 7 and 8. So 8 digits are here, 1 2, 3, 4, 5, 6, 7 and 8. Now here this is the D0 of pin of the port D. This one represents the D1, D2 up to D7. So from left to right it's D0 to D7. This represents the whole port D now. Initially, in case of a cathode, 1, 2, 3, 4. Initially, as told you earlier, in case of a cathode, if you send 0 to the digit pin, then the digit gets enabled. So it means that 1 means digit is disabled. I write it in case of cathode. 1 means digit is disabled. So by default, the digit must be off. So we send 1. D0, D1, D2 and D3, D4 we are using here. D4 is our unit digit. This is the 10th digit and this is our, you can say, 100 digit and this is the 1000 digit. So they all must be off by default. Now to display the value, we take the initial state of the digit here. Now the unit digit, that is the digit 4, I make it 0. Now guys, what I do here is that I write a command port B equals to display this variable. Instead of 10, I will write the value here, this variable. Whatever the value is, its unit digit will be displayed here. So I give this symbol mode of 10. Now this mode of 10 is something I show you here. Now what does mode of 10 means? This mode of 10 means that this is our unit digit D1, this is our this is our unit digit, this is our 10th digit, this is our 100 digit and this is our 1000 digit. Now at the unit digit, once it reaches 0 to 9 value, whenever it becomes 10, then the control has to be transferred to the 10th digit. And this transfer of control is done by this mode symbol, that the remainder is taken and rest of the digits are transferred. So this mode, basically it's a remainder symbol. A remainder will be taken and the control will be transferred to the next digit. That's why it is needed. Now I go to the initial state. Now this technique is basically called a multiplexing technique. One by one the digits will be displayed. Now we have to give an adequate delay here. So we write delay ms25. Now this delay is very important. You have to balance between two things. One is the triggering speed. If it is very high, the high is the better, because it will make your display look more stable, like no blinking is taking place. But if it's low, it will look like the digits are being displayed one by one. But you have to balance between human eye and watching that. If you make it too fast, like for a counter, everything will change in just a moment. So you have to make sure this delay, that is something you have to play with in every code you make. So now we have displayed a digit at the unit place. This digit, whatever the unit digit of this is, will be displayed by this command on the port B on the 7th segment. Now this digit has to be disabled. Now with disable, go to the initial state. Oh sorry, I pressed the wrong button. Okay, I copy this and I paste it. Now it has gone into the initial state again. Now for the 10th digit, just copy this till here, paste it. Now this will be our 10th digit. For the 10th digit, you disable the unit digit again and enable the 10th digit like this. That is at pin number D3, D0, D1, D2. At pin number D2 of the PIC, we have our 10th digit. So we enable it. And now you have to add something here. You have to divide it by 10 to make the 10th digit. Divide it by 10. Now this is our 10th digit. Because value is now divided by 10, now again the control has to be transferred to the next digit, that is a 100 digit. Now we again write, again once a digit is displayed, we hold it, we keep it on the screen for some time for the human eye to see, and then we disable the digit again. Now this is called multiplexing technique. Digits are being displayed one by one, but at such a speed that human eye don't understands. Now disable the unit 10th digit and enable the 100 digit, that is at D1. Now to make it 100 digit, add a 0 here. Now it's a 100 digit of the value, and now again go to the initial state. Now again copy this. Now we go to the 1000 digit. For the 1000 digit, that is at pin number D0 and that is the digit 1. So we enable the digit 0, D0 pin and disable rest of the digits and we make it 1000. Now this is the 1000 digit which will be displayed. Now to verify this, our code is working or not, I comment this and I give a manual value to the display, like I give the value equals to 1, 2, 3, 4 like this. It will be just 1, 2, 3, 4 to be displayed on the screen. I build this code, check for errors. Okay, there are no errors. I go to the MikroC for PIC programming tool. I select the hex file. I click on write. Okay, the code is being written. Okay, the code is burned. I get to the hardware and I give 5 volt from the ticket 3.5. See that it is displaying digit at a very fast speed, but I make it translucent because this is because of camera that we cannot capture the rate. I just add a translucent screen, so it will be easy to see. So okay, I just added a translucent screen so you can see a bit better. It's basically displaying 1, 2, 3, 4 but at a very fast speed. So because camera cannot capture this, but you can see that it's 1, 2, 3, 4 basically. I try to show you. See that? Now this blinking speed, we can control it. We can change these delays to control the blinking speed. I make them 5 now. 5, 5, 5 to all the 4 digits. It is displaying the correct value. Now we have to adjust the blinking speed. So I build the code, I change the code, I click on write. Let me zoom out and let's get to the hardware. Okay, the code is being written as you can see. So guys, the new code is burned. Now you can see that there is no blinking. We had just lowered down the delay. See, at 5 there is no, you can see just shuttering because camera cannot show you directly. So I am using this translucent screen as well. See that it's 1, 2, 3, 4 without any error. So we simply change some values here. Let me zoom in. I make it 3, 2, 1, 4 like this. I build this code and I write this. Let's see, does it change as well? I click on write. Okay, the new code is being written. Let me zoom out. Let it write the new code. See that is 3214 without any blinking. So this is basically multiplexing. We are triggering at such a high speed that our eye think that it's continuously on. So in this camera, this is showing some shuttering because it is red light, but in reality it is completely stable. So let's continue with our programming. This problem is solved. Now we have our code for displaying data. Now we need to display the value of this. Now we uncomment this. Now whatever the value coming from the LDR must be displayed on the screen. So we build this code and see does it work or not. I click on write. Okay, the new file is being written. Let's get to the hardware. Okay, the new file has been written. It's showing 592, 591 value. Now what I do is that I place a finger on the LDR. This is the LDR. See the value drops. It has become 390 something. I place finger on it. It drops nearly to 0. This means that it is showing the correct values. Let me show you. I hope I can make it clearer. Okay, it's now 595. I place the finger. See the value drops. It's like 134, 135. See, I place the finger again it drops. Now see that the blinking has increased. We again lower down the delay further because now this delay has added up. So we make them less, like 2, 2, 2 and 2. This will do fine. You can play with this code. I will give you this code in the Google Drive. Now I write the new file with load delay. Let me build it again. Okay, it's written. Let's get to the hardware. Let me zoom out. The new code is being burned. Okay, it's burned. See, it has become more stable now because I load down the delay. Now I place a finger on the LDR. See, its value drops, like it's very quickly changing the values. That is what happens when you give so much delay, that the values will change at a rapid pace now. See, now it's a stable value. So if it's an unstable value, it will change at a rapid pace. See that it's working fine. It's like 600. So now we program the LED that whenever the value drops below, so I place the finger. See, it's like 130, 140. So let me lower down the light by placing a hand on it. So it's fall below 595. So I bring the finger above it. It's like 250. So what I do is that if the value goes below 200, then the LED must turn on. That's the condition I add. So if I write here, if val, okay, it's better I write it here. If val is less than 200, then LED at which pin it is C.F0, which is initially off, this will turn on. So LED at C0 will turn on, else we write that it will remain off. So it is off like this and it's on here. So whenever the value drops below 200, LED turns on, else it's off. So now we build this code and we go to the hardware. Let me zoom out. Okay, the code is built. This is the hardware. The previous code is working. I click on write. The new code is being written. Let's wait for the new code to be written. Let me write the new code. Now this LED will come into play as well. Okay, the new code is written. Now we place the finger. The value, as soon as it goes below 200, the LED will turn on. So I place the finger. See, the LED turns on whenever the value goes below 200. See, I place the finger on it, LED is on. Value is below 200, I remove the finger, LED turns off. See, now the value is below 200, LED is on, else it's off. Again, the value is below 200, LED is off, on, else it's off. So at 200 it's blinking, so we make it 300. Let's go back. I make it 300, it will be more stable. So let's build the new code and burn it. This is the hardware. Where our previous code is working, I click on write. The new code is being written. Let's wait. Okay, the new code is written. So it's 605. Now it should go below 300 and LED will turn on. See, it's on. So it's like, I can take it like whenever the finger comes in front, LED turns on. It indicates that finger has been detected. No, it's not. Finger has been detected. Or it's dark in the room. LED on means there is a dark in the room. Like you make a light, whenever it goes dark, light turns on. By default, the light of the room is 600. So you can use it as a threshold. So this segment will be very useful for making a threshold. See, I place a finger, it turns on the LED. By default, the value is 599, 600. So guys, I hope you learned something from this video. If you have any questions, you can ask in the comments. I will share the MikroC for PIC file in a link in the Google Drive. You can download it from there as much time as you want. So still you have any questions, you can ask them in the comments. So thank you very much for your time and have a nice day.